Let's set the scene for this whole section by talking about where AI in agriculture has come from and, more importantly, what's genuinely different now. For more than a decade, precision agriculture has made good use of machine learning, yield maps, soil variability models, early warning systems for pests and disease. These are genuinely useful, but each one is a specialist tool. It does one thing with structured data, and it produces a number or a flag. Generative AI is a different animal altogether. Instead of predicting a value, it generates something new, a plan, a summary, a report draft, an answer to a question you hadn't predefined. That's powered by large language models, or LLMs, which have been trained on enormous amounts of text, including a huge amount of agronomic, scientific, and commercial content, so they arrive with real background knowledge baked in. Then there are multimodal systems, which take that a step further and can work across images, tables, PDFs, and maps, not just text. And that last point is why this matters so much in agriculture specifically. The sector runs on unstructured information, scribbled field notes, vet visit reports, regulatory PDFs, drone imagery. These new tools can actually engage with that kind of material in a way the old ML models simply couldn't. So why does this matter right now for people working in farms and food businesses? The first reason is practical. LLMs can actually read the documents agriculture generates: a soil health report, a food safety audit, a supplier contract, and do something useful with them. The second is flexibility. Unlike a dedicated ML model that you have to retrain for each new task, a single LLM can help with crop planning in the morning, supplier benchmarking after lunch, and a compliance document before end of day. You can bring in a drone image, an NDVI map, or a lab report, and work with all of it in the same session. And crucially, the cost and accessibility picture has completely changed. These aren't tools that require a data science team to deploy. They're embedded in tools people already use: Word, Excel, email clients. It's no longer about whether the technology exists or whether you can afford it. It's about knowing how to use it effectively, and that's exactly what this course is here to help with. One thing that can cause real confusion is the loosely interchangeable way people use words like AI assistant, Copilot, and agent, so it's worth being clear about what each actually means. A copilot is essentially an intelligent companion sitting alongside your work. It can draft a sentence, suggest a formula, or flag something unusual, but you're in the driving seat the whole time. A chatbot or assistant is conversational. You ask, it answers. An agent is the more autonomous end of the spectrum. It can take a goal, break it down into steps, use tools, like searching the web, and work through a task without you managing every move. That distinction really matters in practice, because the appropriate level of oversight is very different. You'd check a Copilot suggestion the same way you'd proofread your own work. You might let an agent run a research task unattended, but you'd still want to review what it came back with before acting on it. Most people working in agriculture will move between all three of these modes depending on what they're doing, and the course will help you figure out which one fits which job. Building on those definitions, it's helpful to think about three distinct modes of working with AI: asking, automating, and delegating. Asking is the most familiar. You type something, the model responds, you decide what to do with it. Automating takes a step further. The same prompt or workflow runs on a schedule or when something triggers it, so you're not manually involved each time. Think of a daily summary of field sensor alerts. Delegating goes furthest. You give an agent a goal, and it works out its own steps, using tools and making intermediate decisions to get there. Each mode comes with a different design requirement and a different risk profile. Automation is efficient but inflexible. It does exactly what you set it up to do, no more. Delegation is more powerful and adaptable, but it also means the AI is making more decisions without your direct input. So your guardrails need to be stronger. Recognizing which mode you're operating in at any given moment is genuinely one of the most important skills you'll develop through this course. There are 3 AI platforms that appear throughout this course, and it's worth getting clear on where each one tends to shine. ChatGPT from OpenAI is the most widely known. It's versatile, well-suited to research, drafting, brainstorming, and working with data, and it has a strong ecosystem of plugins and integrations. Claude from Anthropic has a notably large context window, meaning it can process much longer documents in a single session, which makes it particularly well-suited to reading through lengthy reports, regulatory standards, or contracts. Microsoft 365 Copilot is different in character. It's embedded directly in the tools many agricultural and food businesses already use: Word, Excel, PowerPoint. So it works inside existing workflows rather than requiring you to switch to a separate interface. For most tasks in this course, any of the 3 could be used. Matching tool to task is something you'll get better at naturally as you use these systems. But a few rules of thumb help from the start. For fast, operational tasks on the farm. Drafting a field instruction, looking up a supplier, summarizing a meeting note. ChatGPT or Copilot inside Teams tends to be fast and friction-free. For deeper agronomic analysis, where you're synthesizing multiple research sources or interpreting a complex report, Claude's ability to hold a long document in context makes it genuinely more capable. Compliance and standards work. Reading a 200-page food safety standard, for example, is where Claude's context window really stands out. For data work in spreadsheets, Excel with Copilot is the natural home. For more exploratory analysis, ChatGPT's code interpreter is surprisingly powerful. And for producing polished outputs, reports, presentations, communications, Word and PowerPoint with Copilot let you stay inside the tools. The key variables to weigh up are: how long is the source material? What kind of data are you working with? What format does the output need to be in? And does it need to connect to any existing system? Now it's time to get hands-on and start building some intuition for how these tools actually behave in an agricultural context. You'll be working in a browser with access to ChatGPT, but everything in this exercise works with the free tier. You'll find a file in the course folder called agscenariobrief.txt. This is a short paragraph describing a fictional mixed farm. It covers the crops being grown, the time of year, recent weather, and a couple of pressing operational questions the farm manager is dealing with. Take a moment to read through it so you understand the context. Now copy the contents of that file and paste it into ChatGPT as your first message. Adding the instruction. Based on this farm situation, suggest the 3 most important decisions the farm manager should be making this week, and explain your reasoning for each. Read the response carefully. Notice how the model has interpreted the scenario and how it has framed its reasoning. Now try a follow-up. Ask it to present the same 3 decisions as a brief table with columns for decision, key risk if delayed, and suggested action. This exercise gives you a feel for 2 things. First, how quickly a well-framed prompt can generate genuinely useful decision support. And second, how the same underlying information can be reshaped into different output formats just by changing how you ask.